Okay, this video will help guide you through the assessment at the end of lesson 1.7, which I'm going to remind you counts as the application portion of this unit's test. You can see that what it's asking us to do is sketch a graph of polynomial functions. We're supposed to design and sketch a real-life example of a polynomial function, basically search for an image, and then create the function accordingly. So I'm going to show you, what I think you should do to do a great job on this. So I'm going to go to Google, and I'm going to search an image of Neuschwanstein Castle. Okay, and I'm going to say this one back here. Maybe this one actually looks good, right? And we're going to get this this castle, and what I want to do is I want to bring it into GeoGebra. So what I'm going to do is I'll save it, save image as Neuschwanstein, good, okay, and then I'm going to go to GeoGebra, and if you look at here under this last option here, graphics view, this one, sorry, the slider. So this one here with the slider, we're going to go to image and Neuschwanstein and open. Now, this gives me the image into GeoGebra, which is great. It's what I want. Once you have the image in here, there's a couple of things we can do. I'm just going to quickly resize this. Sorry. There's a couple of things we can do once we're in here, which namely like we can change its size, right? So like if you grab the bottom left corner, you will move the object. If you grab the bottom right corner, if you just grab one corner, you will stretch it. Okay, so sorry, before I had them both picked. So I want to grab one corner, move it around. Let's sort of get it to where I want it here. Maybe somewhere like this. And then I'll make it a little bit bigger. And then that's good. Now, one of the reasons this is really good to do on GeoGebra is something I'm going to show you right now, which is if you go over here to the empty space, and then you enable the auxiliary objects, okay? So the picture is an auxiliary object. It doesn't show by default, right? But if you enable the auxiliary objects, you can see it. Alternatively, you can just right-click the picture and pick properties. That'll work just as well. But I like putting it over here because I can like easily hide it if I need. But more importantly, if I go to Object Properties, and then I head over here to Color, okay? And then what I'm going to do is I'm going to take the object's opacity down to, let's say, 40% or so that I can still get a very good sense of my grid behind the image. So now, again, let's say, I want my function to, let's say, model this like rolling hill in the background, right? I'm thinking to myself, okay, well this one, it opens sort of down, and then it comes up a little bit, and then it opens down again. So what I would suggest, the reason I think you want to try to do it this way, is so that we can set it so that the intercepts sort of line up in convenient places, right? So for example, I could put an intercept over here at, let's say, x plus 6, roughly over there, another one at x plus 2, and then another one maybe at x minus 2, and then of course I want the one at x plus 2, so I'm thinking about this one right here. I want this one to bounce off the axis, which as you saw in lesson 1.7 is accomplished by having a order 2 root, right? So you put 2 of them rather than 1. Now of course, once I have this, right, I've kind of got the basics of what my function's going to do, but I need to flip it upside down for one thing, and for two, obviously my function right now is way too tall, right? I need it to be a lot smaller. So let's try, altering the a value at the front to give it a vertical compression. So let's try like 1 over 10, for example. And you can see 1 over 10 is still not enough. So maybe let's try 1 over 50. Right, and 1 over 50 you can see is not bad, right? I'm getting there. I kind of need to like, maybe I can move this around a little bit and try and get this to line up a bit better and so on. But you kind of see the idea of the assignment, right? You want to pick something that has a nice, background image that you can use, and maybe as you kind of play around with it, you're like, well, maybe I want to use this mountain over here instead, right? And maybe I can follow that mountain a little easier if I like pull in this final one to maybe like 1.25, and yeah, like maybe I pull it in a little bit more, -1. And anyway, you kind of get the idea, right? You pick an image that you think shows a good example of a polynomial, right? So maybe the way I had it before or the way I have it now, and you just want. I'm not looking for it to be perfect, right? I just want it to be a good, generally a good match using a polynomial to track like. Landscape is good. A lot of people showed like pictures of you know, uh, roller coasters. I think are good. Certain art and so on. But anything you think that might work, and then your goal is to sort of make this function. Okay, you're going to want to submit the image and the function, and then the assignment is simply to, describe all of these things. Now, sketch. I don't need you to sketch it. You can just submit a screenshot of whatever your final image kind of looks like is perfectly fine for that. So it doesn't, it says sketch, but don't worry about sort of sketching it. Just giving a screenshot is good. And then you're going to have to tell me its degree, the sign of the coefficient, its end behavior, its domain and range, its intercepts, and then the equation. Remember, if you're looking for its range and you have something like mine, what you could do here is you could like use a point, right, to sort of search in this area. What's the highest number you ever see it go to? It's like over here. It's kind of like, okay, can I get it any higher than 853? I can't really get it any higher than that, right? So I'm gonna, and again, it doesn't need to be like perfect, right? Just as kind of close as you can. So it looks like this is about as high as I can get mine, 85333, right? Which happens right there. I could double check on this side that it's kind of the same, and then I would know what my range is. So you can always use like a point, just to confirm what you think about the range, right? So it looks like this side is more or less the same. Like I can get it to be about the same value. I don't think I can get it to go any higher than that. Okay, so whenever we're going to go and write the range for this one, I'd say x can be any, or the domain would be x can be any real number, but the range y must be less than 0.85333. Okay, so that's just a quick tutorial. Again, just to summarize, you want to save the image onto your computer. You want to go to GeoGebra and hit image, right, which is what's going to allow you to pull the image into GeoGebra. And then most importantly, once the image is in, you can right-click the image itself, go to properties, and change the opacity so that it's easier to like see the grid, and then you can design your function that way. I would like it to be, remember, in order to be advanced functions, it should be degree 3 or higher. 3 or 4 is fine, but don't make it 2. And it should be a good match. Like, I don't know how good my match is here, honestly. I mean, I'd sort of, maybe I'd have to sort of mess around with this a little bit more. Maybe look for like maybe this mountain over here instead. It might be better. I don't think my match here is very good, but of course I just did this in 2 minutes, right? So I would expect you to take a bit more time. Maybe find an image where you've got like a nice visual that you think fits, and then take your time to design a polynomial that tracks it, as well as you can. I'm not expecting perfection, but maybe a little better than what I managed to do here. Okay, and again, of course, any questions, please post to the forum. This counts as a test mark, but is not really a test, right? You can take as much time as you want with it, and it doesn't need to be, it's not timed or anything like that. Okay, so again, feel free to reach out if there are any questions.